Hello, this is our virtual prototype and our circuit diagram of the water trash collector. Now, if you may notice, there is an H-bridge included. This was not included in our initial project proposal, I will note. But the reason that an H-bridge is included here is because the virtual prototype does indeed work without an H-bridge, but only if the rotations per minute are at a low count. If the count increases, the motor and microprocessor are in danger of being damaged, and that is why there is an H bridge included. All in all, the circuit does indeed work, so as long as there is a motor driver with the motor and microprocessors. Here you can see the change in RPM of the DC motor, so you can see that it is indeed working. You can't see clearly because of the low quality, but they are indeed working.
The first part of the code is the pin declaration. In this section, we assign each component to a specific pin on the Arduino. For example, 2 pins are set aside for the DC motors, one for the rotary potentiometer and one for the on and off switch. By declaring these at the start, the Arduino knows which pin controls each device. Next is the void setup function, which runs once the Arduino is powered on. Here, the motor pins are set as outputs because they send signals to run the motors, while the switch is set as an input with a pull-up resistor so the Arduino can detect whether it is turned on or off. This makes sure all components are properly initialized before the system starts working. The loop function is the main part of the program that runs continuously. It first checks the state of the switch. If the switch is pressed, the system turns on. The Arduino then reads the value of the potentiometer, which ranges from 0 to 1023, and converts it into motor speed value from 0 to 255 using the map function. This way, turning the potentiometer changes how fast the motors will spin. When the switch is on, the Arduino sends the mapped values to the DC motors. Using the analog write function, this makes the conveyor motor and the propeller motor spin at the same time and same speed, allowing the device to move on water while collecting trash. On the other hand, if the switch is off, the Arduino will immediately stop both motors by setting their output to 0, ensuring the device shuts down safely. In summary, the code will allow the trash collector to be controlled simply by the switch powers the whole system on or off, while the potentiometer gives flexible control over the motor speed. This makes the device easy to operate while still being effective in moving and collecting trash from the water.
Let me explain how our water trash collector device operates based on this flowchart. The process starts when we power on the system. The first decision checks if the device is turned on. If it isn't, nothing happens. The system remains idle until the switch is flipped on. Once the device is turned on, the DC motors begin to operate. These motors are responsible for moving the collector on the water and catching trash using the conveyor mechanism. Next, the system checks the position of the rotary potentiometer. This component controls the motor's speed. If the potentiometer remains in its default position, the motors continue to run at their default speed. However, if the potentiometer is adjusted, the motors will instead run at the new adjusted speed. In both cases, the motors will keep running either at the default or adjusted speed until the potentiometer is moved again or the device is turned on. Once the power is switched off, the entire process stops and the system returns to its starting point, ready for the next operation.